Sample problem. Figure shows a circuit where it is powered by 12 volts power supply with an unknown internal resistance, and it is connected to a low-powered rechargeable battery with unknown EMF and an internal resistance of 1 ohms to an inductor with resistance 3 ohms carrying a current of 2 amperes. The current through the drained battery is 1 ampere in the direction shown in the figure. Find the current of the passing through the 12 volts battery, the internal resistance of the 12 volts battery, and the EMF of the drained battery. First we look at the junctions and determine where we see that we have 2 known currents and 1 unknown current. Junctions A and C are basically the same since the current 2 will be going out from it, so we apply junction rule, KJL, at point A and we have equation A. The current through the second EMF is 3 amperes. We draw the initial loops. We draw loop 1 and loop 2. Looking at loop 1 we see that we have the unknown EMF contained in it and both the resistor and internal resistance are present, so writing an expression for loop 1 we have equation 11. And we get that the EMF at the drained battery is -5 volts. The negative value suggests that the EMF of the drained battery is reversed and it is being charged by the larger EMF battery of 12 volts. Now let us determine the internal resistance of the battery having an EMF of 12 volts. Using loop 2, since it contains the unknown internal resistance and the other known parameters, we write our Kirchhoff loop rule or KLR shown here. We see that the internal resistance of the EMF with 12 volts is 2 ohms. Note that we have retained the negative sign of the first EMF. Using loop 3, since it also contains the unknown internal resistance and the other known parameters, we write our KLR shown here and we get that the internal resistance of the second EMF is 2 ohms.